Hello everyone. In Monday's lecture, we are going to learn all about Pandas data frame, which is going to enable us to store and analyze tabular data. Let's get this lecture started by downloading the template notebook file and a CSV dataset. Go ahead and download the template notebook file which has my name on it. Also download the IMDb movie data CSV file. We are going to be using the CSV dataset during the later part of this lecture. As part of the last video for today's lecture, I'll be going through one of the problems in the worksheet. So go ahead and download the PDF version of the worksheet in order to follow along. The document version of the worksheet right now has some formatting issues. I'm hoping to get that fixed later tonight. Hopefully by the time you watch this video lecture, I would have fixed the format of the document version of the worksheet. I've already downloaded the template notebook file and I've made a copy of it. We are going to get started by doing a quick review of the topic of series that we covered as part of the previous lecture before we start talking about the new concept of data frame. I didn't quite use the term data alignment when I went through examples for element-wise operation between one series and another as part of the previous lecture. Data alignment just refers to the fact that Pandas takes the values and lines them up by considering the index associated with the values. The tricky case is when you have two series which are based off two different dictionaries, and both of those dictionaries have a different ordering of the key value pair. That's when a conflict arises in terms of data alignment. Recall that Pandas series always takes index into consideration for data alignment and not integer possession. Let's do a quick recap of both of those terms. Recall that Python dictionary key is equivalent to index in Pandas series, and Python list index is equivalent to integer possession in Pandas series. Series is this cool data structure which is sort of a hybrid between a dictionary and a list. So each value has two different associated terms. The first one is called index, which is equivalent to Python dictionary key. The second one is called integer possession, which is equivalent to Python list index. Data alignment is a tricky concept, so I want to go through few more examples of that over here. Before I go ahead and go through the rest of this example, I just want to let you know that I have set this example in the template file in such a way that you should be able to go through this entire review without having to watch the part of the lecture video about the review. If you would like to get hands-on experience, go ahead and pause the lecture video and try to answer all of the questions as given in the template notebook file. You can verify your answers by directly checking the notebook file which has the final version. I've already uploaded the other notebook file. Let me go through this problem for you. So we have three series in this example, each of which is created based on a dictionary. Notice that each dictionary has two key value pairs. Both the keys A and B are present in all the dictionaries. But the last dictionary has the order of the key value pair switched. So you get B key first and then A key last. I've displayed all three series after I created that. So this first question is asking what is x into S1. So recall that you can simply say x into S1 in order to compute x into S1, and that does the data alignment automatically for you. And in this particular example, there isn't much work to do for data alignment because both x and S1 have A as the first entry and B as the second entry in terms of the index value that you're able to see when you display the series. Notice that you're applying element-wise operator multiplication symbol here. So you're going to get 10 into 2 and 100 into 3. What's going to happen when you say x into S2? Recall that S2 has a different ordering of the keys A and B, indexes A and B, excuse me. So you have A as the first index in X, whereas in S2, if I had displayed that correctly, you would have B as the first index. Pandas series automatically aligns the index positions here. So you're going to multiply 10 into 2 and 100 into 3. So you're going to get the exact same result that you got when you multiplied x by S1 up on the top over here. Let's go through the next example. The next example is asking x less than S1. Recall that you can also apply comparison operator that will give you a Boolean series as the outcome. So we are going to compare 10 with 2. 10 is not less than 2, so you're going to get false. Then 100 with 3. 100 is not less than 3, so you're going to get a value of false. Here is the tricky example. So what's going to happen when we compare x less than S2? Unfortunately, Pandas series is not built in such a way that it automatically performs data alignment for comparison operators. So this is going to fail with a value error. So I am going to show you how you can actually apply the lesser than comparison operator between the series x and S2 over here. There is a suggestion below that. It says let's try series.lt of series. So let's go ahead and do that. So I'm going to say x.lt of S2. So that's going to enable us to apply the lesser than comparison operator, and this is needed only when you have two different series whose data is not aligned. So notice that because X and S1 had the data aligned in a proper way with respect to the index values, you're not going to have an issue when you say X less than S1. But when you don't have data alignment, Pandas folks decided that they are not going to do the data alignment for you when it comes to comparison operators. Sort of a weird decision, but I am assuming they would have done such a thing to optimize their code for the Pandas series. But good that we have an alternate option over here. LT stands for lesser than, as you might have been able to guess by now. The question below is asking you how you would apply greater than. I am going to actually copy paste this snippet of code so that we can keep modifying that. Greater than is represented by GT. Excuse me, let me go ahead and fix this. Okay, so we can apply the greater than operator by simply saying GT. So we are going to now check if 10 is greater than 3, that's true, and 100 is greater than 2. Sorry, excuse me, I switched the order. Let me go ahead and fix that. So we are going to compare 10 with 2. So 10 is greater than 2, so that's going to give true. And then we are going to compare 100 with 3. 100 is greater than 3, so you're going to get true there as well. So how can we do equal comparison? It's EQ for double equal comparison. So when you compare 10 with 2, you're going to get false, and 100 with 3, you're going to get false, because clearly 10 is not equal to 2 and 100 is not equal to 3. There are three other options that are left out in terms of applying comparison operators between two series. The next option is greater than or equal to. Let's go ahead and apply that. So 10 is greater than or equal to 2, so you're going to get true, and similarly 100 is greater than or equal to 3, so you're going to get a value of true again. So the next operator is going to be less than or equal to. For less than or equal to, you're going to get false and false, because greater than or equal to just gave us true and true. The last option is not equal to. Not equal to should give you a value of true and true. That's because double equal to gave you a value of false and false, right? Clearly, 10 is not equal to 2 and 100 is not equal to 3. So it's a little bit tricky to remember the specific case. Always keep in mind that data alignment happens by using index as the factor to do the alignment. And the second thing is data alignment doesn't automatically happen for comparison operators. So you will have to use the special shortcut words for the comparison operator instead of using the actual mathematical operator for comparison. One final question about this example. This whole problem came about only because we didn't have the data correctly aligned between X and series S2. That's because we had different ordering for the index in uh, X first being A and then next being B, and S2 the first index is B and then the next index is A. So this question is asking, can't we just fix the ordering of S2 series? Yes, we can do that. The way to do that is by using the sort underscore index function. So you can call the sort underscore index function on any series. So if you go ahead and say s2 dot sort underscore index, that's going to sort the S2 values in the series based on the index values. So the index values are A and B. So if I want to go ahead and update S2, I'll have to capture the return value into the S2 variable over here. Let me go ahead and print S2 after this operation. Notice that when I printed S2 above, B was the first index, whereas when I printed S2 after going through the sort underscore index function, A is the first index after that operation. So now you should be able to directly say X is less than S2, and that's going to give you a value of false and false because X has values greater than the actual values in the series S2. Right, that's it for the recap about series. In the next video, I'll start talking about data frames.